Hey guys, my name is Shreyas and welcome to Simple Chemistry. Today we're going to be talking about acids and how we name them. The two types of acids that we're going to be looking at in this course are binary acids and ternary acids. So a binary acid is hydrogen and a nonmetal, and a ternary acid is hydrogen and a polyatomic ion. And there's specific rules to naming them. I'm not going to really read through them. Let's just go ahead and look at some examples here, and then go back to our rules and just learn by example, because I think this is the best way to learn this. So here we have a binary acid because we have hydrogen and then we have a nonmetal, which is chlorine. And chlorine is to the right, chlorine is right here, and it's to the right of the zigzag line on the periodic table. It's to the right of that, so it's a nonmetal. We have hydrogen plus a nonmetal, so this is a binary acid. And the way we name this binary acid is we write hydro for H, so let's go ahead and do that. I'm going to do it up here because I don't have that much room. So hydro, and then we write the nonmetal with an ic ending. So we have chlorine, so we're going to write chloric, and then we write the word just acid. So that's pretty simple. Okay. Now let's look at this. Here we have a ternary acid because we have hydrogen and then we have this polyatomic ion right here. So hydrogen plus a polyatomic ion is a ternary acid. So let's go ahead and look at the rules for that. So what we do here is that we have to identify the type of ion, the name of the ion. That's the most important thing with ternary acids. You know what the ion you're looking at. So SO4 2- is sulfate. Okay. Sulfate. All right. So because we're looking at an ion which ends in 8, it turns into an ic acid. So basically what we do here, just watch carefully, because it's sulfate and it's ending in 8, the name of this acid right here is sulfuric acid. All right. Now here we have phosphite. PO3 3- is phosphite. Okay, so because this is phosphite, since this is an ite ion, it turns into an us acid. So the way we name this acid is phosphorus acid. Okay, so basically you have to just look at the end of the you have to look at the polyatomic ion, identify if it's an ate or an ite ion, and based on that, we either use the ic ending or the us ending, and then we just write the word acid. Pretty simple. Now let's work backwards here. Here we have a backwards, meaning we have the name, and we're just going to have to write the chemical formula. So we have a binary acid here because we have hydro. So we're looking at a binary acid. And a binary acid is a hydrogen and a nonmetal. So we know for a fact this is going to have hydrogen, so let's just go ahead and write that down right now. And if you look carefully, again, the rules for naming a binary acid is we write hydro and then we write the nonmetal with the ic ending. So we have bromic, right? So kind of think backwards here. If it's bromic, the name of the element we're looking at is bromin. Bromin right here, Br, bromin. So that's why it's very important that you know your elements and you know them well, because if you don't, then this is going to be confusing. But bromic, work backwards, take the ic ending and turn it back into what element it is bromin. So that is Br. Now we're going to have to balance the charges here because to make sure the compound we're looking at here is neutral, because all compounds are neutral. Hydrogen has a +1 charge, okay, because it's in this row right here. Hydrogen will have a +1 charge, and bromin is going to have a -1 charge because it's in this row right here. And this, what I'm talking about, is oxidation states. If you don't know what oxidation states are, I would advise you to go watch our video on oxidation states. So this bromine right here has a -1 charge. So we have +1, -1, they're balanced, the charges are balanced, so hydrobromic acid is just HBr. Now, sulfurous acid. So since we don't have the hydro in front of it, we know we're looking at a polyatomic ion. Now, we have an us ending, so we're looking at a polyatomic ion, a ternary acid, and basically what I mean is we have to look at the polyatomic ion. So we're looking at a ternary acid because we don't have that hydro in the beginning, and we know it's an ite ion. It's an ite ion because it has the us ending. So the only ite ion which has the sulfur is sulfite. Okay, sulfite because it has the sulfur and then it has the ite ending, and the way we know it has the ite ending is because of this us right here. It's a little confusing, but just bear with me. So sulfite, we know that's the polyatomic ion we're looking at. Sulfite is SO3 2-, and we're going to have to balance that with H, okay, with hydrogen. So we're going to need, since this has a -2 charge, we're going to need a +2 charge to balance that out. And since hydrogen has a +1 charge, that means we're going to have 2 hydrogens to balance out the SO3, the sulfite. So H2SO3. Okay, each hydrogen has a +1 charge, multiply that by 2 to get a +2 charge, and they balance out. So sulfurous acid is H2SO3. It's basically working backwards. You have to be smart about that, okay? Now, we have another acid. We know it's a ternary acid because we don't see the hydro at the beginning, so it's a ternary acid. We're looking at dichromic, okay? So that means we're looking at an ate ion because it's an ic acid. It's an ic acid ending in ic, so it's an ate ion. So the polyatomic ion, which starts with dichrome and ends in ate, is just dichromate. Dichromate. And the formula for dichromate is Cr2O7 2-. And in order to balance this out, we're going to need to have 2 hydrogens because each hydrogen, this has a -2 charge, each hydrogen has a +1 charge, so we're going to need 2 hydrogens to get a +2 charge to get everything to balance out. So at the end, we will get H2Cr2O7, and that's dichromic acid. And acids are as simple as that. Again, please do the practice quiz to master this concept. But that's it for now. Naming acids is as simple as that.